Although the environment around an organism changes, the organism maintains relatively stable internal conditions. This ability to maintain internal stability is called homeostasis. For example, if a person stands in a cold wintry night or hot sub-Saharan Africa, the person is able to maintain a normal internal body temperature between 36 to 37 degrees or 97 to 99 degrees Fahrenheit through homeostasis. The main mechanism to maintain a homeostatic environment is through negative feedback. Negative feedback is where the body senses change and activates mechanisms that negate or reverses it. The term homeostasis was coined by an American physiologist, Walter Cannon, to explain this tendency to maintain internal stability of the body. However, the internal stability that is maintained is not absolute. Rather, the internal state is maintained between a limited range, and it is useful to use the term dynamic equilibrium. And a good example of this is the internal body temperature, which is usually maintained between 36 degrees and 37 degrees, for example. Again, the main mechanism to maintain a homeostatic environment is through negative feedback. So let's look at how the body maintains normal body temperatures using negative feedback. The stimulus is, for example, here an increase in body temperature because perhaps the person is exercising or it's super hot outside. This increase in body temperature will be detected by the brain, which is the control center, and will activate mechanisms to lose heat to keep your body cool, and this is done via the hypothalamus. The hypothalamus will send signals out that will cause vasodilation, which is widening of the vessels. When blood vessels of the skin dilate, warm blood flows closer to the body's surface and loses heat to the surrounding air. If this is not enough to return your temperature to normal, sweating occurs through activation of sweat glands, and sweating is the evaporation of water from the skin and has a powerful cooling effect. Now, you can imagine when it is hot outside, you are sweating and appear flushed from the dilation of the superficial blood vessels in the skin. All these mechanisms are causing the body to reduce the body's internal temperature. When the body's internal temperature returns to normal, the brain's hypothalamus heat loss center shuts off. And this is done through negative feedback. The negative feedback essentially stops the hypothalamus's heat loss center because the body does not need to lose any more heat. Conversely, if the stimulus causes a decrease in body temperature, such as the cold weather outside, let us just say your body temperature drops much below 36 degrees Celsius, the brain, which is the control center, activates heat conserving mechanisms. The first to be activated is vasoconstriction, a narrowing of the blood vessel in the skin, which serves to retain warm blood deeper in your body and minimize heat loss from the skin. If this is not enough, the brain activates shivering muscle contractions, tremors that will generate heat. These mechanisms increase body temperature, and when the body temperature is back to normal, there will be a negative feedback to the brain telling it to shut off the heat-promoting centers. So body temperature will increase and the hypothalamus heat-promoting center will shut off. So that was an example of how negative feedback works to maintain an internal stability, and we used temperature, internal body temperature as an example.